Hi, it's your math facilitator Naomi Andrigg, and this is a quick video on graphing lines that are already in point slope form. So point slope form is if you have y minus some number equal to the slope, some number, times x minus some other number. And here the point would be, the point in point slope form, one point that this line would go through would be x naught y naught, and you can see that x naught y naught would make it true because if you put x naught in for x, you'd have x naught minus x naught. Well, that's just 0, so the right hand side would be 0. And then if you put y naught in for y, that side would also be 0. So the equation would be true just because both sides would be 0 if I put these two values in for x and y. Now the slope, if I actually multiplied m times x and m times this number and then added stuff, or I guess I would add stuff over here, I would still end up with an m as the coefficient of x. And we know that in our normal slope-intercept form, the coefficient of x is the slope. So this coefficient of x, since it would be the coefficient of x if I multiplied out, would still be the slope. So our slope is just m. So let's look at an example. So this first example here, we have y minus 1 equals negative 2/3 x minus 1. So the slope here would just be this coefficient, and then the point would be, this is our x coordinate and this is our y coordinate. So we have, let's see, point would be, note that it's a positive 1 and not a negative 1 because it's minus x naught. So this would be a positive 1. And then the slope would be negative 2/3. And of course, we go ahead and associate the negative there with the 2 and go down 2 when we're using the slope to find a second point. So over here on the graph, I would start, I know that one point on the graph of this line is 1, 1. And I know to get to the next point from this point, I go down 2 from that negative 2 and right 3. I always go to the right. So that gives me a second point. And after I have these 2 points, I can graph the line. I just draw a line through the 2 points, like so. And then I have this equation graphed. So notice that I didn't have to go through multiplying things out or getting it in slope-intercept form or anything like that. I can just easily find one point, the point that makes both sides 0, and then I can easily find the slope, and I can use the point and the slope to graph it. Okay, now for a second example. So the second example will work exactly the same way. We have to start by identifying a point, preferably the one point that makes both sides 0. And that would be 7 would make this side 0, 2 would make this side 0. So 7, 2 is one point on the graph of this equation. The slope, of course, is just the coefficient of x in general. So it's going to be this 1/2. And I think of this as rise over run. My rise will be 1, my run will be 2, and I'm always running to the right. So if I want to graph this equation, I would start by graphing 7, 2, which is over 7 up to right here. And then from there, I would need to go up 1 and right 2 to find another point. So I would go up 1, right 2, right there. And then I just draw the line through these 2 points, and that's it. Now you can see if I had gone through putting this in slope-intercept form, I would have ended up with a yucky fractional intercept to try to graph with, and that probably wouldn't have been the easiest way to do it. It's a lot easier to find this one point that makes both sides 0 and the slope, and use that one point and the slope in order to graph it. Okay, let's do just one more. I wanted to make sure I did one where the initial point isn't made up of 2 positive integers, where we have a negative integer, and maybe something with a whole number for the slope too. Okay, So here, this is still slope or point slope form. Now here we don't have anything subtracted, we have something added, but we know that subtracting a negative number is the same thing as adding a positive number. So we can think of this as a minus negative 3, and we can think of this over here as a minus negative 4. So here my point, using that point slope format, would be x is negative 4, because that's what would make the right 0, and then y would be negative 3, since that's what makes the left side 0. The slope here is going to be 2. If you prefer to think of it as 2 over 1, of course we can do that. 2 divided by 1 is the same thing as 2. And you can see by writing it out as a fraction that we're going to rise 2 and still go right or run 1. So graphing this equation, we know we're going to start with a point negative 4, negative 3, which is left 4, down 3, right there. From there we're going to use the slope to find another point, and we're going to go up 2, right 1 from that point. We could do that a few times. Sometimes it's good to do that a few times, especially if you're graphing by hand, just to kind of get an idea of where this is going. And we can graph the line through these points. They should, all line up if you're always going up 2, right 1. And this is the graph of this line. Okay. I hope this helps. Now, lastly, after you figure out how and get comfortable graphing things that are already in point slope form, it's nice to be able to go backwards. It's nice to be able to be given, let's say you're given the point is 1, 2, and that the slope is 3. You want to be able to go backwards. Take this equation. This is our point slope form general equation, and you can find an equation from the point and the slope. So x naught here would be 1. I can just replace this with 1. Made it little. And then y naught would be 2, so I'd replace that with 2. And then the slope would be 3, so I replace that with 3. And then I have already the equation of a line that goes through the point 1, 2 and has a slope of 3. So point slope form kind of allows you to go back and forth a little easier than slope intercept form does. Okay,